Welcome back to the stream, early stream folks, and anybody coming up in the archives to listen to this one. So here we're going to be trying out some 3D printed parts fresh off the printer, and starting to get this robot partially assembled into something that looks more like a robot. And of course, Tuco is on the rack again. So this is a continuation of the project to build a little robot that can fly around the shop on nylon cords and hang out with my cat, give him a little audience-controlled streaming camera on Twitch, which will be a first step in a platform which I'm sure will involve a whole bunch of little robots that can throw bolts and otherwise interact with him around here. But yeah, one step at a time. So today I have some parts freshly 3D printed, although a lot of this is stuff that I did the CAD design for kind of off stream too, so maybe I should start out by just going through the CAD and then we can take a look at the parts that I've got. Cat stream, indeed, we have cat. As we have cat, I find myself wondering if I have mouse. I think I have mouse, but the table I'm using makes a terrible mouse pad. Alright, I think as cute as Tuco is, I'm going to try to move things along and get him in picture for a little while. Actually, maybe we can use this one. Is that the right one? I think that's the right one. Alright, so here we are back in Fusion 360. This is the design so far for the flying part of the robot. So down here I have kind of a placeholder for the gimbal. This big cylinder is it's just a representation of the area that the gimbal and the camera can move in. So just kind of a keep out region for that. And then up here, man, that is a terrible mouse pad. Anti-static mat makes a better mouse pad, but it was full. So up here somewhere I've got the actual gimbal. Yeah, so this is a 3D model of the bottom plate of the actual gimbal. So this is actually a circuit board with kind of a weird shape that the gimbal uses as a mounting bracket and as an electrical breakout. So on the bottom side, that's what actually mounts the gimbal motor. The sort of weird positioning here is actually so that the axis of the yaw motor is centered in this whole thing. So the motor is not centered in that board, but I'm kind of recentering the motor so then the board is off center. And then the gimbal is actually held onto these two 3D printed parts with M6 bolts, which are structurally a little overkill, but they were the right diameter. And then that sandwiches these two 3D printed brackets together. The bottom one is mostly there as a faceplate to provide the right shape here to give me some mounting locations for another cylindrical layer above this. And then this U-shaped piece is the kind of structural clamp that holds this onto these two carbon fiber rods. So this is just another PLA piece. I might reprint this with a stronger plastic, but right now I just have this in PLA and it seems fine. So the idea here is that I have a pretty tight fit between the carbon fiber rods and these holes, and then there's a place for an M3 bolt to just cinch that down really snug so that these rods don't go anywhere. And so these rods are holding up the weight of the camera down here through these two brackets and the gimbal assembly. And then on the top end of these rods, which is a 1/2 meter away, Then we have this whole assembly, which looks kind of weird right now. Let's maybe take this one step at a time. So yeah, so here we just have our carbon rods. The next piece is this thing I've been calling the sensor saucer. And as you can see, it's kind of saucer shaped and it's covered in sensors. These aren't all the sensors. There's also going to be a motion sensor, where by that I mean like a radar, like nearby object moving with respect to this thing sensor. There's also going to be an IMU, so measuring acceleration and orientation relative to, to gravity, and measuring this thing's reference, or measuring this thing's motion. And so those are going to go elsewhere, but up here, this ring holds all of the light sensors that form a perimeter around the gimbal down here. So the idea here is somewhere in here, if I turn on the right, yeah. So you can see some of these ghost outlines here of the parts that I've highlighted. Those actually represent the locations where these sensors are sensitive. So my goal here is to try to create kind of a little cage that surrounds the gimbal, but doesn't actually detect the gimbal itself. So I don't want the presence of this gimbal, regardless of how it moves, I don't want that to be picked up by the IR sensors. But if an object is about to bump into our robot, we want to know about it. So that's the goal here. And as you might guess, that seems a little bit difficult to do accurately, so that's why I wanted to try to test this piece relatively early on in the design. So I've got this piece of plastic. It's over here. Yeah, so this piece of plastic that's highlighted in blue, this is a 3D printed mount that actually holds these 3 LiDAR sensors, which are the kind of binocular-looking ones in a triangular arrangement, and then 8 of these infrared rangefinders. And so the LiDAR sensors are flat. The IR sensors are angled slightly. I don't remember how many degrees this is, but I think it's like 5 or 10 degrees, so that it should clear the gimbal on the other end of here. So there are a few things I'm worried about. I'm worried about these detecting the gimbal itself. I'm worried about them not being sensitive enough at this distance. I'm worried about them, well, I'm a little worried about this IR sensor getting a reflection off of the barrel of this LiDAR sensor, things like that. I've tried to do some testing so far that makes it look like these problems are probably fine the way I've designed this, but those still are the most risky aspects of the design right now. So all the sensors just attach here with screws. The wires feed to the top side of the plate here, what we're looking at. And then there's room on top of that for another piece. So we've got some M3 bolts and the carbon fiber rod still protruding from the top of that. Then there's this piece that I've been calling the tie-off ring. And so it's kind of weird. This is actually where the nylon cords come in from the winches, so it's kind of an important load-bearing part for the robot. So the nylon cords each go through these channels in these arms here. The arms are really mostly to keep the nylon cords from interfering with anything above or below this layer, so we want to kind of space the cords out to the edge of the robot before they start moving around outside of our control. But mostly the idea behind the load-bearing part of this is that the cord goes through this channel and then curves up and then exits the top of this 3D printed piece, and then I tie a knot in it. So the knot actually is pressing against this whole stack of 3D printed layers. And then if you imagine each of these layers just in isolation, each one is kind of a little loop around the cord here, and then a nearby loop around the carbon fiber rod. And so we actually have to support 4 of these around here, so actually structurally it's important that this is like a ring. So I'm hoping this works out like that. I've got this fairly beefy ring here. This is like, I think, 20 millimeters thick, and I'm printing this in NT glass, since that should be a little flexible and won't just crack like PLA if it's under stress. And then it has a similar clamping arrangement where the carbon fiber rod goes through a pretty snug cylindrical hole here, and then there's a bolt here that applies some extra clamping pressure. And then these bolts additionally hold the sensor saucer onto this main clamped piece. And then there's also a little room for another piece above here that I haven't designed yet, which will mainly just be an aesthetic cover and a holder for some LEDs that are mostly for camera navigation aids. But yeah, the top will just be kind of the whatever we want the top of the robot to look like, including LEDs or whatever. And then this is where the tether for the robot goes through. There's room for, I forget what the actual measurement is, but I think it's like 1/2 inch diameter or something, maybe 3/4 inch diameter, kind of crinkly convoluted tubing that covers a few wires that we'll need. There's some speaker cable for 12 volts DC, there's a coax for video, and there's Ethernet. And so that goes right through down the middle. I wanted that to kind of go down to the center of mass of the robot if possible. So that's one of a few that's one of a few reasons I went with these 2 carbon fiber tubes side by side. That leaves room for the wire to go down the middle and then to a strain relief that I can anchor to the tubes here. This also is spaced to leave enough room for the microcontroller circuit board to hang out between the two, which makes it easy to mount that such that I also have it centered with center of gravity. And yeah, so the whole snake of wire can go down here, and then the wires can go to wherever they need to go. The coax will go pretty much all the way down. The DC power wire will go to some DC-DC converters here somewhere. The Ethernet will plug into the microcontroller. And there'll be like a clamping arrangement up here that I haven't designed yet to be a strain relief. So this piece here in blue is what's printing right now, but I have the sensor saucer, so we can assemble that and at least test to see if the sensors work like I'm expecting they will. There's the tie-off ring printing right now in blue T-glass. Good old cat. Alright, so I think the next step here is to take a look at our printouts. So here's the gimbal. It's always seems a little fragile because I've got these heavy parts and these delicate parts all connected together. So there's this very tiny coax with this fairly heavy connector at the end, and then there are all these joints with this relatively heavy camera hanging off of them. So it'll be nice to get that actually assembled. This is what I've got so far for the bottom of the flyer. Focus. Oh, not on that. All right. Okay. So pretty much like what we just had in CAD. I don't think I tightened these yet. Or maybe I did. No, this is not tightened. So I have this pushed all the way through so that you can see, yeah, you can see the end of the carbon rod resting up against that lip right where it's supposed to go. I wanted to avoid tightening these until I put the other half on so that it was easier to keep them parallel. I noticed that just by tightening this, it was easy to get them kind of tilted in the hole as it was going together. And right now, these 2 pieces of plastic are just being held together by friction against the carbon rod. But once this is assembled, the bolts that hold the gimbal on also hold those 2 pieces together. So I could put the gimbal in here right now. I've just been avoiding doing that because that makes the whole thing a little harder to work with. So, and then on the other side, I've just got bare tubes. And then this is the first sensor saucer I printed. As you can see, I've already got all the LiDARs installed and they fit really nicely. And it has all of these cutouts for the IR sensors. And you can see they're kind of stair-stepped because the IR sensors are all angled a little bit. That's part of why 3D printing this piece was so nice. I could get all those angles set just the way I wanted them. And then likewise on the back. Well, you can see one problem with this piece. I printed this with the brim, which was actually super annoying to clean up around all of these screw holes. So I've only done a couple of them so far. Yeah, you can see that doesn't look pretty, but it's angled the same as the matching hole on the other side, so the screw shouldn't want to split the plastic right there. The problem with this piece, oh, where did I put the IR sensors? Here's one. So I have this cutout for the IR sensor, but unfortunately my CAD model had a mistake on how wide this circuit board was, so I did not leave enough room for the circuit board to fit in there. And so I tried doing some testing with this kind of held at the right angle, but just not pressed in all the way, but it's not really accurate, so couldn't really do that much more with this piece. So this piece goes back to scrap after I take the LiDARs off of it. But we have a shiny new reprint with the modified CAD model with much more space for the circuit board. So let's assemble this and see how well it works. This is fresh off the printer. I printed this one without a brim, since it seemed like based on the shape I wouldn't have to worry about warping, and that seemed like it was right. And so it's pretty clean already. There's a little bit of stringing here that we can just take off really easily, but the main cleanup I'll need to do here is to take any boogers off the edges here and to actually remount these carbon fiber rod holes to get exactly the right fit. Oh, thanks. Our GM in chat says, loving this series of vids. Thanks so much for sharing. Well, thanks so much for stopping by. I hope we all have fun with this cat robot. Let's see if I can maybe get this camera robot's assistance in focusing while I work on this. Oh, doing this looking at the monitor instead of the knife is going to be a good way to hurt myself. Oh, I think I really got to show this part of the CAD, but I'm liking how I ended up using this central hole. Oh, that didn't focus at all, did it? I'm liking how this central hole in the saucer ended up working out. Since it's pretty oversized, I just didn't need this material for anything anyway, so I gave it a decent amount of material to hold the carbon fiber rod, but then just took out a circle here. But it left plenty of room for the kind of umbilical cable for the robot, and then also enough room that I could take all the wiring I need for the top side. So the sensor wiring has to go back down to the microcontroller, and then there's also wiring for some LEDs on the top, and so all that can actually go around the perimeter here. So there's actually a concentric bundle of cables where the sensors go on the outside, and then the leash goes on the inside. Okay, there's like a random booger right over here. Man, it's so hard to keep this stuff in focus. It's also just so hard to see details on black 3D prints. You have to get the lighting just right. I mean, it can look really nice, but it's a photography challenge for sure. I made this piece black mostly to match all the sensors. And I think, I'm still thinking about how the aesthetics for this robot are going to work out. I think it makes sense for the top of the flyer to be pretty unobtrusive because I don't really want it to be the focus of attention. So I ended up printing the tie-off layer in blue tea glass because I had some, and it's a really nice shade. But that'll be pretty subtle because that piece is mostly hidden. So anything that's like big like this, I was trying to make a pretty subtle shade that won't take that much attention away from the camera part. And then there's a piece I haven't designed yet that'll hold some LEDs in probably a set of 2 or 3 stacked rings right above the gimbal. And that I think will be more like a visual focus. But because I'll have LEDs inside, I'll probably be printing that out of translucent white filament. And then, so that means that the top is going to be probably like designed to blend in, and then the bottom is going to be designed to light up and or blend in, so that doesn't leave me a lot of aesthetic freedom. And so part of this is I'm looking for a good spot for that awesome Tuco Flyer logo that Misty designed. So, but there's this whole space on the sides of the carbon fiber rods where it's going to be a little bit ugly inside. Like I'll have some wiring going up and down, and so I think I'm going to want something to cover up the innards of the robot. And so one option that I've been strongly leaning toward is to 3D print basically little half-cylinder shells that just snap onto the carbon fiber rods on each side. And then you could just snap off those shells for maintenance. I think that would work out nicely. If I did that, I could 3D print them out of a variety of materials, but it would also be nice to try to put on that Tuco Flyer graphic. I'm having trouble imagining a perfect way of doing that because the Tuco Flyer logo looks really good in landscape, and this will be a really weird kind of portrait aspect ratio, but maybe I can make it work anyway. And then material-wise, like, it could be a 3D printed thing that then holds a piece of sheet material. So maybe I make it out of like a plastic sheet covered in cut vinyl that then seats into a 3D printed bracket that holds it in the right curve. So that way I get the benefit of a nice flat sheet material that's easy to print on and gives me a high quality image, but then 3D printed bracket that holds it onto the carbon fiber rod maybe. All right. This is one of my favorite tools for cleaning up 3D prints. It's literally just a piece of spring steel with some notches and some silicone tape as a handle. And it's nice because it's not sharp. Well, it's a little sharp. I very slightly sharpened it, but it's dull enough that you can use it without really worrying too much about damaging the model. But it's sharp enough to knock off any cobwebs and boogers and stuff that you usually have on 3D prints. And I designed this particular shape to be the same width as an LED strip because I had a lot of things I was doing at the time that LED strips fit into. Anyway, I'm not going to worry too much about every single cobweb here because a lot of these I can clean up as I put the IRs in. And then the other side actually should be pretty good because I printed this one without brim, thankfully. So cleaning the brim out of all these holes would have been annoying. Okay, let's get the LiDARs ready to put in here. Oh yeah, Jarrett says maybe kind of eye-shaped cross-section for those shrouds instead of straight-up cylinder. Yeah, totally. That came to my mind also, and yeah, I like that too, because that reduces the total weight and makes it a little easier to see a flat graphic. So yeah, I like that a lot. So I think I could just design the cross-section. I might want to put that off until I have the brackets designed for the microcontroller and the motion sensor, because those are going to be the two biggest pieces that have to fit in the middle. But once I know exactly how big those are, I can figure out how much room is left for graphics. Oh, nice. Kate Timken in chat says, I'd be tempted to get a bright LED and then shine it through a cutout of the logo so it projects the logo like straight up onto the ceiling. That would be fun. Oh, could I do that? There's room for a little bit, there's that piece that I haven't designed yet that goes above the tie-off bar that would hold the navigation LEDs. One downside is that unless I have the right optics on there, I would be like blinding my navigation camera, but that's fine. The other issue is it couldn't be right in the middle because that's where the cable tether needs to go, but it could probably be off-center. It might break symmetry if it was off-center and I only had one of them, but that's probably fine. Like I said, I said earlier that this robot already has some weird symmetries going on because I've got 8 of the IR sensors and 3 of the LiDAR sensors, and then I've got this kind of bilateral symmetry for the part down the middle. I mean, it would be nice to have more mathematically compatible symmetries, but, you know, 8 seemed like the right number of IR sensors, and 3 was the number of LiDAR sensors that I happened to have for this project, so. Well, besides the one on the gimbal, it was 4 total. But yeah, I was experimenting with a few different designs for this sensor saucer, and I really like this particular layout that ended up allowing it to be so thin, where the LiDARs mount through from the bottom, but then the IRs press in from the top. I was trying to keep this level from sticking out too far because then I worry about it getting in the way of the line of sight for the IR sensors and having kind of false triggering based on reflections off the side of these. I don't know exactly how many LEDs I'm putting on this yet. I'm probably going to use some fairly dense, like the 144 per meter, which I was measuring them actually to do the CAD models, and I think they might actually be specified. Like as I was measuring, they ended up being like exactly like some round number to the 10th millimeter. Like I think it was like 6.9 millimeters between LEDs or something like that. So anyway, those are the ones I have, and they're really nice and close together, so with the right diffusion on top, I think that can make a nice ring where I can create effects where it just looks like the LED light is moving side to side instead of it being discrete points. So that's what I want for the, for the kind of human-facing end going downward. But then on the top, I want some LEDs on top kind of as navigation lights. Those won't really be visible from most of the shop. I'll be able to see them from like the loft area. But mostly what I want those for is for the overhead camera view that'll be kind of like the mini-map. And for that, I just want points of light that'll be easy for humans and computers to detect. So for that, I'll probably use some lower density LED strip with no diffusion over it. So I just have maybe 4 little strips that are lined up over the nylon cord exits, and then each one has like, 3 LEDs perhaps. They can do simple animations such that you can detect which one is which. Could do it with invisible LEDs too, but I think it's kind of fun to make that part visible. And I think I could have it adjust the brightness so that it doesn't, it's not super bright at night. So it wouldn't need to be. Alright, so this one's junk now. Oh, let's actually take one of these carbon fiber rods totally out so we can test the hole. Excuse me, that tea is dangerous stuff. Oh, Jared asks, what happened with the scrap printed parts anyway? It depends on the shape, and it depends on what kind of material you have. Since this is PLA, and I don't have my own recycling facilities, and as far as I know, you can't just recycle loose PLA parts around here. If it's something that I'm not personally going to reuse, it just has to go in the garbage. But I've been saving the kind of big, flattish failed prints because they make just like good scrap material to glue stuff to for mock-ups of stuff or whatever, or to like cut apart. And so I've got a bin of of those particular kinds of failures, of which that seemed like a good example. So I save some of them, but then I throw away a lot of them, if that answers your question. Yeah, it seems like it might almost be worthwhile sometimes to get into making my own filament from recycled materials, but the tools to get into doing that are kind of expensive. And I don't know, it seems like more of something that would then turn into a whole other area of experimentation. Like you'd have to figure out all these process variations to get just the right kind of filament, and to figure out the mix of recycled to new filament, and get the diameter control just right. And so it's just this, like, it's kind of more like the early days of 3D printing in general, where there's this large space of process control problems that people haven't really figured out how to make viable for hobbyists and small scale producers in general. So it's like making your own filament at home is interesting to me as a potential hobby, but doesn't seem like, like an economically viable kind of thing yet. It'd be nice to be able to try kind of custom filament formulations for sure. Oh, there we go. I'll make sure the surface in here is smooth. I'm sorry if this noise bothers you. I mean, it's not the greatest noise, but just imagine how great the cat camera is going to be. I wonder if I have any drill bits that are close to this size. Or maybe any, like a file that I could ream this out with. So that feels like it needs a little more. Yeah, let's try, see if I have a drill bit that's close to that I can use. How close is this to my rod? This is a 5/16 drill, which looks really close to the rod diameter. The piece above this needs to have like clamping force, but this piece doesn't have to really clamp. It just has to, I just want it to be kind of a snug fit. There's a few twists through there. Cleans it right up. Ooh, nice hole. Well, kind of hard to see the shininess in there. Yeah, I really like the logo. Yeah, that was done by, I think their Twitter handle is _Misty with a 1. Yeah. Oh, that's nice. It's not quite as tight as I would have liked, but with the clamp above it, it'll be fine. I don't want it to be overly constrained, so I'm happy with that. Oh, also, I think these carbon fiber rods might have a wider end and a narrower end, and I think I was going to put the wider end on top. Let's see if this is the wider end. Ooh, yeah, that's the wider end. Great. Oh, that's perfect. Because I had sized the one on bottom for the narrower end. The wider end is actually significantly wider. Huh. Whew. Well then. Yeah, I don't want to break that. Let's actually give it a little more drill. Uh-oh, is this stuck? This is not good. I have a carbon fiber rod stuck partially into this piece that I just printed. And now I'm worried about breaking both, like breaking the rod off in the hole. Huh. I mean, I could put something that diameter on top and try to pound it out. I mean, I could probably apply some heat, but I don't want to break. I mean, that's going to mess up my plastic part too. Oh, wait, I think I might be getting it. A little bit of wiggling. Just need to not worry so much about getting this part on camera. Okay, great. Okay, a little more drill. In fact, I could use the actual drill and maybe save my fingers. Oh, that was a good suggestion from John, to put something that diameter on the table and then press the thing down on it. That was a good idea. That probably would have worked. I was struggling to find something the right size because it's sort of a weird diameter. But yeah, maybe I might have been able to find like a circuit board standoff or something that would have been the right size, or like maybe an M3 bolt with a bunch of nuts on the end. Or M4, something with a flat head like a socket cap screw. Yeah, I barely got it. Thanks for the hint anyway. So, how much that helped and if I need more. Carefully so it doesn't get also there's, so one of these sides should be, so that's definitely the small side. That's like way too big. But then this is the side that's at risk of getting stuck, and I think this needs more drilling. That's interesting that they would be so different. I'm curious if they were like hanging as the epoxy was curing or something. I don't know if I have another drill bit that's just a little bit bigger than this one. Okay, so that's the, oh, that's nice. So that's the snug end, but it's still manageable. And then that's the loose end. Great. Oh, that's what I want. That is holding it pretty firmly, but easy to move around. That's what I want. Except I'm putting this in backwards. It actually goes this way. Great. And then if we put this together, the other piece. A little more snug, but still fine. I'll take that. Cool. Well, I don't really want to assemble this quite yet, since I think I want to put the sensors in first. I think I might actually drill this right one out slightly, because this is tighter than I think I'd like. Let's see if it's just a difference in the carbon rods, or if the holes. Let's try putting this rod in that hole. Yeah, that rod is a little bit thicker, but this hole is also a little bit narrower. Let's just drill them both out a tiny bit more, and then call that done. This doesn't have to clamp it. Okay, I think we can stop fussing with those holes for now. When I actually assemble this, I'm going to want the other piece on top, and then I'm also going to want to make sure I have the right amount of rod sticking up above that. And so I think I want to have all the structural parts on the top and bottom ready to go before I start clamping stuff into place. And then there's stuff in the middle, like the mounts for the electronics, that I can add afterwards. Okay, let's take this out for now. I gotta remember which side is the small one and which side's the long one. I'm gonna put both of the short sides back in their bottom bracket where they belong. Yeah, so I'll just put this aside. Alright, let's test fit the IR next, since that's what we had trouble with. Well, so far so good. So this just goes through the hole. sure just putting the wires through the hole is probably going to be the most annoying part. Alright, and then I think I want shorter screws. I may have not even bothered to put the screws in the cab model. I'm a bad person. I think M3x8s will work fine. So, yeah, M3x8s look just right. I guess it's probably easier to put all the IR sensors in before I do any of the LiDARs, because the LiDARs are kind of big. Get a little spanner for tightening these. Probably have a better tool for M3 nuts, but this is what I had handy. I didn't actually print nut-shaped indentations into the back like I probably should have. Alright, there's one installed. We can just check out how that fit looks. I think that looks alright. I think we assembly line the rest of these. I have a big bag of these sensors somewhere. Mitch says the features for holding the IR sensors make it look a bit like the a Star Wars faction logo. Yeah, it kind of does, doesn't it? Looks like some piece of like space war equipment of some kind. Possibly a retaining ring for a critical Death Star component. Oh, Mikkel asks, any progress on the winch bot, or is that a problem for later? I've been thinking about that. I haven't actually done any CAD for that. I still haven't really settled on a design. I think mostly I'm trying to decide whether or not I want to try gearing. Because one design I imagine is to have maybe 8mm threaded shaft down the middle of the winch, bearings on either side, and then printing a gear into the perimeter of the winch, or of the spool, and then having another gear on the output of the gearbox I have. I think it might be useful to have a little bit more reduction, so that might be helpful. And that helps with the coupling problem. The main concern I have with the 3D printed gear is noise. I think it's going to be loud. From what I've been reading, if you break in the gearbox and then lubricate it, you can actually print some pretty good 3D printed gears. So I might try that approach, but I'm skeptical. The other thing on my mind is keeping them less. So if I decide, okay, no gearing, if that's the path I'm on, then it's probably easiest to keep the motor shaft concentric with the winch shaft. And then I have an idea for how to do a flexible coupler that doesn't take up much additional space, because I'm worried about making the winch bots so thick that they're hard to mount on the wall then. So, and it would be easier for a coupler to just make the whole thing way bigger. So if I can kind of fold part of the coupler design into the spool, then I think I can fix that. But then it makes supporting the spool sufficiently a little harder. And so I think there are a few ways I could support the spool then. One kind of novel way I've been thinking, I guess, is to have to basically roll the spool around on bearings, but then you end up having like a bearing on plastic rolling interface, which is maybe fine, but maybe a source of wobble and noise problems again. So ideally you don't want any like plastic parts sliding against other plastic parts. You want all the interfaces to be nice like metal bearings. So if you're going down that route, then maybe I look for some bearings with a really large inner diameter that can just fit around all the space that I need the coupler assembly to take up. And mostly that means the inner diameter needs to be larger than the, well, I was going to say there's like a protruding part of the motor, but that was on the previous motor, so maybe that's not even true. So maybe it just has to be any bearing with a large enough inner diameter that I can support it, like I can support that inner diameter with 3D printed parts effectively. So not like like a 8mm bearing or whatever. I can only support that shaft with like a bolt, which means I can't put additional stuff through that. But if I have something wide enough where I can have like an 8mm shaft going through it, and then some 3D printed parts for the coupler, and then some 3D printed parts to support the bearing, and then the bearing. So maybe it's a large bearing, and maybe that's expensive, and I don't want to go there. So there's trade-offs in that design too. So yeah, still thinking about where to go there. I might just try to print out some 3D gearbox designs other people have done just to evaluate how I think they might work. Right now the printer is busy with parts for this, but I might do one of those on my small printer, which isn't as accurate but is faster, so I could at least try some stuff and see how well it works. So many sensors. It's going to start getting a little unwieldy as soon as I start wiring all these sensors up. I'm wondering if the wires on these sensors are long enough that I can run them all the way back to the microcontroller, or if I'm going to have a little, like a little consolidator board somewhere that just, like maybe I design this so that you can plug a ribbon cable of some sort into some pins on the micro. And then there's something, I don't know. I think I can keep the micro pretty close to all these sensors. It's just that at the very least, I think I need the cable snake strain relief to be between the micros and the sensors, so that limits how much I can get away with the wires being really short. So like, for example, that reaches all the way down there, which I think is plenty. So maybe that's fine. Anyway, so all those are mounted. Let's put some screws in. I'm just going to put them in enough that they're sticking out on the back so I can get some nuts on the back. I definitely need to get the winch bot redesigned because that's going to quickly become the blocker. Some of those bolts are kind of rusty. I could actually put stainless bolts in. I think I have enough stainless bolts, but then I'd have the shiny fasteners. I don't know if that would look good. Usually I'm all about stainless hardware, but this part of the robot is trying not to be flashy. The stainless hardware tends to be a lot more expensive than the non-stainless stuff. It is nice though. I mean, I think I've got enough. I could switch to a different kind of bolt. I mean, I have other bolts here. It just means I have to change all the ones that I put in already. It is flashy, just in the IR spectrum. Very good point. This is very flashy in the IR spectrum. It's full of infrared bling at many different modulations. Warning, it's sharp. I haven't decided how to do power distribution. I mean, it probably makes sense to just have a big old solder joint where I tie all the IR sensors down to a little 2-pin wiring harness for +5 and ground. Mazu says to put washers under the nuts. I don't think I have enough washers of just the right size, so why are you suggesting to put washers under the nuts? I can think of a lot of reasons to use washers, but on a joint like this where you're just bolting 2 pieces of plastic together that aren't going to move at all, I'm not really sure why you would use washers. There's the IRs so far. I need some nuts on the back. And I'm going to go ahead and thread these through this direction. Oh, this would be really good use for a little socket driver. I should see if I have one. Oh, is the suggestion for putting washers under the nuts for spreading out the force on the plastic? Like, that would be nice. I just don't have this many tiny washers in the right size, so no washers today. And I think we'll be fine. I mean, this is all with the grain of the plastic, so I'm not really that worried about it. You know, it might make this a little bit convenient if I don't know, I was just imagining adding like a drop of glue on the nut to hold the angle, but I could also see that being a problem. Just making it easier to disassemble without the nuts getting lost. James asks, is the plan to have the data output lines of the IR sensors all individual, or to gang them up somehow? That seems like a lot of pins. They're all individual. This processor's got plenty of analog inputs, so we're fine. Yeah, there's 8 analog IR sensors and 4 LiDARs. And the microcontroller is just going to handle reading all of those, and it's going to be great. I mean, it already works fine. I already wrote the firmware for that. I've already played with that on previous streams. Okay, let's see if I have a driver that will make it easier to tighten these. This might have the right bit. Is that the largest one? Oh, and it's not quite big enough. Yeah. Maybe the non-micro socket set has an M. I guess that would be an M6. Alright, screw it. I'm tired of looking for stuff. I'll just use pliers. Oh, that's nice and snug. Great. Oh yeah, James suggests not gluing the nuts unless you have really viscous glue. This capillary action can often suck the glue into the nut threads. Yeah. Yeah, definitely not something to try with your average super glue. A little daub of 2-part epoxy would probably be fine. James Mastro's in chat, the other James, is suggesting nut-shaped holes. That's what I usually do. I was just kind of lazy when I designed this part, so I made the holes round. I think there are probably some new Fusion 360 features I've learned about since designing this even that would probably make it easier to do the right thing. I was just lazy at the time, and I think the feature I was missing was arraying features. So a lot of the way this worked was by, well, I had a component for the IR sensor, and then in that component I made a body which was the stuff that I wanted to, like my template for stuff that I wanted to remove. And that piece knew how to like create the IR sensor side of the hole, but I didn't have a template for the other side of the hole because that depended on the depth of the material you're mounting it in. So I was just lazy and I didn't make a template for that. And then I went in on a separate step, and when I drew them, I just put circles there. I don't know why I just put circles there, but it seemed fine. Man, we're really overthinking this one little aspect, aren't we? Before I really do too much worrying about how the wiring harness works, I just want to test the sensors. So I'm going to use a little tiny breadboard for power distribution, and then just, how do I get these sensors back to the, that's right, they need a, so I need the breadboard for little resistor dividers also, because these sensor, or no, that's not true, that was for the, I'm getting this confused with a different sensor. Now the analog output of this can go directly back to an I/O pin. So it just needs some way of connecting this wire to a jumper. All right. Got that. And cool. Then the LiDAR sensors. And these actually, I think I want to trim off some of these wires that I'm not using, because I'm only actually using 3 wires off of these. I don't know. I don't want to cut them completely off just in case, but I want to at least make it easier to identify the wires that I am using. That step seems easy to do right now. So I've got, I think this is ground. And I think I have 2 unused wires. Then the PWM signal, 1 unused wire, and the power wire is red. PWM and another unused. Little wires. More screws. These can also be M8s or M3x8s. I think, oh no, these need to be a little longer. I think these should be M3x10s. Oops. Let's do these one at a time. Fewer things to hold. Oh, Ryan asks if it would be possible to lower the Gitter notification volume. That's a good question. I, a lot of the time, don't know where that's coming from because it's often not something I actually planned on. It's just that if I have one of the Gitter clients running on one of these machines, yeah, and then the Gitter client doesn't actually have a volume control, so it'll just be whatever the system volume on that machine was set to. Yeah, I don't know. I kind of hate that, and I think I might just stop using the Windows Gitter client because I don't think I have enough control over how it actually notifies. And I think the Windows Gitter client was the only one that actually had that sound, as far as I know. to be more focusy. Yeah, the getter notifications are usually loud in person here too, because they just don't have a volume control. Michael says open Gitter in a different browser. So the browser version of Gitter is not the one that's making noises, it's the native version. And I mean, I could check to see if the Windows volume mixer thing lists it as a separate program. I don't think I checked that. Yeah, and my plan with the notification was actually just to try to stop using that one entirely and just have visual notifications if I need to, because, oh, I'm spacing out on who made it, but somebody was really kind and made a, like a little program for Raspberry Pi that would flash an LED for notification, and I just need to get that set up over here. I also just, there's this part of my brain that's always just like working against the whole idea of having notifications because I just hate being interrupted. But like an LED seems like an alright compromise. Brian asks if it's Windows 7. Why would it be Windows 7? No, it's Windows 10. Oh, 7 and up. Okay, that makes more sense. Okay, everything's in. I just want to tighten these somewhat. And then we can hook this up to the microcontroller and see how it performs. I'm realizing that to test these, I'll want them connected to the microcontroller, but I want the microcontroller itself out of the way of the sensors. So one way of doing that is to have them all plugged in without going through the center here, just stay behind here. That might be the simplest thing to do right now, especially if I'm just wiring it all temporary-like. The other option is to pass it through like I'm going to be, and then since I don't have the mounting bracket for the microcontroller yet, I could just tape the microcontroller in place on the carbon rods where it's going to go. Which seems kind of nice, but maybe just assembling it kind of beside this actual thing would be fine for testing this. I don't know, I'm getting to the point where I don't want to have to like rewire these sensors after I wire them, so maybe I just think about how they actually go together and wire that in a more permanent fashion. I mean, either way, I don't want to create something ideally that I have to that like I want it to be easy to take apart, so I don't know. It'll be a balance between how many connectors I use to keep it easy to take apart in the future and how many connectors I don't use because it's annoying to assemble it that way. Did I already tighten this? I think these are already tightened. All right. So. Yeah, look at all that. So the piece that goes on top of this actually has a bunch of channels for this wiring to hopefully fit nicely into. It might be a pain to get the wiring to all sit in the right place. But yeah, that kind of sits there. Another piece goes on top. And then all of these plug into the microcontroller in the middle. Kind of like that. Looking more like an actual robot thing. These carbon rods feel pretty nice. I mean, there's some like rotational ability here, of course, but that'll be significantly less once I clamp them down. All right. Well, for testing, let's maybe just keep all the wiring on the top side. And then we can worry about passing it down through the next piece once that's done printing. And I'm just going to maybe keep that on the end because I do actually want that there as a placeholder for the gimbal. Alright. Oh, maybe I'll put that there after the wiring. This is unwieldy. Okay, wiring. This is the part I'm not looking forward to. Okay. We also don't have to do this all at once. We could just start out wiring one sensor and then see how well that works, and then wire more sensors. Maybe let's try that. These little tiny wires just barely fit in that breadboard. All right. Free up this device so I can bring it over there. All right. There's the microcontroller. So it sucks working on something that's broken, so let's actually just try to get this working first, and then we can add some functionality to it. So we already have one sensor, the IMU, attached, so let's just power this on and get the telemetry back. Oh, we also have the connector for LEDs, which will be fun. Okay. So this got Ethernet and 5-volt power. Power 150 milliamps, and it seems happy. Let's get back in there and see if it is actually happy. Welcome back to the computer. Oh, look at that telemetry. Already streaming through. Oh yeah, I don't know if I ever actually showed the IMU working on stream. I think we were having some problems with it, and then I just kind of magically fixed it and then didn't demo it. Oh, terminal. Do I need to restart terminal? Is that the kind of computing experience I'm having right now? Okay, so these are the telemetry values coming back over UDP. A lot of these sensors just aren't connected. Like, this sensor is just floating right now. Great. But then we have, for example, we have a quaternion here, which should change as I move this sensor around. Don't know what that was. That was like a random... Oh, that was a gimbal packet, since we also have a floating input on the gimbal. So, I got IMU packets. It's the acceleration gyroscope. Anyway, so let's build on that. You can see we have some noise coming back in over the IR inputs. So let's figure out where to connect those. Bot firmware. So PE0, or PE3 rather, seems to be a good place to stick these. Alright, so I've got a couple of these handy already, presumably from last time I used them. These two pins. So some more of those great super long headers. Looking for a good place to grab 5 volts from this board. 5 volts and ground. Ah. Oh, what happened to the camera? Are we having a video switcher problem here? Huh, looks like we lost the webcam. Oh no, we lost the Blackmagic input. Why? Oh. I don't actually know how to fix this without restarting. Decklink 3. Oh, can I do that? Cool. That was a huge hack. I just switched to a different recorder and then back, which only works because I have another recorder for Tuco Flyer that isn't currently being used because I'm not running that stream right now. Okay, let's hope that sticks. Oh, but yeah, so Ash was asking what the IR sensors are for. Yeah, generally I'm trying to keep people from bumping into things with the gimbal. So just trying to establish a perimeter around the camera with some sensors. Okay. Okay, can I make these any bigger? Okay, the numbers we're going to care about are probably IR0 and maybe IR1 if I connect that one. So I think this first one is just going to be IR0. It doesn't seem right, does it? Oh, I plugged it into the wrong place. That seems better. Okay, so this number next to the mouse is the IR0 reading. Which one is that specifically? It's this one right here. Okay, so it idles around. I really need to graph this stuff. But yeah. Okay, let's get a new camera angle and put the carbon fiber rods on there. All right, let's go up. All right, so that's roughly where the camera's going to be. The camera's going to be up here. So, and again, this is super annoying because the values after IR0 are just flapping around. Maybe I can ground IR1 to make this a little easier to read. Okay, so IR1 should be reading near 0 now. The others are still oscillating. And sometimes my terminal freezes. That's cool. So if I move in, ooh. So I can detect right about there. Now what about coming in from the other side? Oh, I think we're right on. I'm trying to illustrate this, but it looks like we start to get a little bit of detection a few inches out from the actual gimbal, like right about there. I think my calculations and CAD model might have led this in the right direction. It's looking all right so far. I'd really like to get this data graphed. I'm still trying to figure out what the software stack I want to use for that is. I think what this looks like is maybe one of the next steps is I actually start trying to build the server that runs the robot. So right now the robot's a pile of microcontrollers that talk over Ethernet, over UDP. And the microcontrollers don't really do much. They just do the really low-level hardware interfacing. I'll have a PC doing the actual computer vision and higher level tasks, and then that's also a convenient place to run the kind of middle levels, like, you know, doing the kind of higher level motion control stuff that is not quite as latency sensitive, but is stuff that I'll want to edit a lot. That stuff goes in the PC. So I think I'm going to write that in Rust, and I'm just now learning Rust. This will be like my first Rust project, so there's that overhead. But I think maybe it'll be pretty quick just to get that to a point where I can use it to proxy telemetry and gimbal commands back out over to WebSockets, and then I can just use smoothie charts to graph it in the browser. So I think I'm happy with that. Let's hook up a few more of these sensors. I really just don't want to do any throwaway work on this. I'm pretty happy with how these sensors work, and I just kind of want to connect them in a fairly final way at this point. So I'm finding myself pretty low in motivation to do another test like this. And also, these wires are really not very breadboard friendly. They're super short. I mean, the stripped ends are really short. Can we get maybe 3 sensors for testing at least? I've got the breakouts for the first 0 and 1 at least. Where does 2 go? PE1. Going around in a little circle. I have a third sensor. Oh, the ground lead is really tenuously connected. There goes it disconnecting. Yeah, maybe I should just solder all the power together. Because I mean, maybe the thing to do with the analog sensors is to... I mean, the moment I do that, though, I'm kind of committing myself to this particular saucer piece, though, because then it's hard to unwire everything. Well, let's at least just breadboard 3 of these, despite the breadboard being annoying. Okay, I think those are connected. So we should have 0, 1, and 2 giving us good data now. Whoa, that's kind of concerning. What is that? Is that right? Zero seem... Oh, there's 0. Oh, those are connected. That's 0, 1, 2. Are we getting interference at this point? This is about where the graphing would be super handy. It's a little hard to tell if this is working right without the graph. And it is noisier than I'd like, which I can only assume would be crosstalk between sensors. I don't know, I thought I had enough... I mean, these sensors have so much built-in baffling. That's very reflective. That's not going to help. Alright, well maybe I know what I have to do next. This is looking like I need to graph this data, which is going to require some more software yak shaving, which probably is not super interesting to stream. It looks like it's kind of working, but I'm worried about the interference. It might be an electrical problem also. Maybe we should take a look at this on the scope. And it could be that I just need to make a little circuit board that breaks out the power and maybe also has capacitors or something, depending on how this goes. Probably would not hurt to give these sensors some additional power filtering, because I think they're driving a modulated IR LED, which seems kind of noisy. Oops, let's go... Oh, I'm probably gonna have to reset the O-scope grabber also. Or by reset, I mean momentarily switch to a completely unrelated thing. let's start out with just one channel. I turned off the lights because I thought those might have been interfering, and now it's really dark in here. More headers. Oh yeah, that does not look good, does it? One more channel maybe? If this is interference between the sensors, I might have to put up some kind of baffling in between them. Or increase the radius, have them be farther apart from each other. Never enough grounds. Oh yeah, Jack is suggesting maybe, just running the sensors in sequence instead of running them all continuously. Yeah, that's an option. That would require some firmware changes, but it'd be doable. The timing on this is really interesting. I mean, it's not looking so noisy that it's unusable, but it's certainly not optimal. What do I have that would be a good light blocking material for this maybe? Well, I have some really dark black paper here. Let's try that. Okay, so which two sensors are these? Let's also maybe simplify this so we only have two sensors. I have 3 plugged in right now, but only 2 on the scope. Not that one. This one. I think I unplugged the correct sensor. Okay, so this sensor is green, and that sensor is yellow. sure this paper is probably too reflective in IR. That's interesting. Okay, how does this change when I unplug one of the two sensors? Because we haven't ruled out that this is just environmental noise. That's definitely a lot cleaner. Yeah, so maybe we pull them sequentially. It looks like the sensor itself is not updating very fast though, like it's internally only updating every 40 milliseconds. Oh, well, if that's the case, then these are probably too high power to drive directly from I/O pins, so we'll need some kind of other driver. I like that suggestion about driving maybe every other one. Maybe we'll see, let's see if that causes interference. Let's just unplug all these and plug in two particular ones. Let's take this one and this one. I'm worried about if I scan them sequentially, I don't know how long they take to power on and then settle into a reliable reading. So that'll be something to watch out for. I might also just have to redesign this ring to optically separate them better. Is that working? So now it's this one, and that one. That's still got some interference, huh? I could try powering one of these off of a function generator. It might just be I can filter out the noise and still use them for obstacle detection. I mean, this is definitely usable with every other turned on. Let's try plugging the one in between those two and see if that still seems usable. Oh, I should strip these wires longer. They're so short. These O's got probes. Nope. one more channel maybe? Can we do that? Oh, let's have these overlapping a lot less, please. That's enough. I mean, the primary goal is detecting an obstacle. Detecting exactly where the obstacle is secondary. Oh. Oh, different scales. I mean, the level of noise changes pretty dramatically depending on whether there's an obstacle. But yeah, I don't know if that'll be usable actually. That's just getting worse the more sensors I add, huh? Okay, and also, I'm also more interested in the effects like up here at around a half meter, which are also a little harder to tell with all that noise. All right, let's check out maybe the startup behavior, like for turning the sensor on and off. How quickly does it respond? So let's clean this up a little bit, and I need to grab a signal generator. Oh wait, the scope has a signal generator. Yes, I could use that. I just need a cable for it. Okay, I think I've only got one sensor plugged in. Yeah, this is much cleaner. Imagine that. It'd be really nice if we could synchronize with those measurement cycles the sensor is obviously doing. So Ash was saying that some low-pass filters should work well since the update rate is low. I guess what I'm worried about partially is that I don't know if all the noise is going to cancel out because the more... It's like we've got a lot of modulation patterns that are all fairly similar to each other, so I think we're going to end up with interferences that have like annoyingly low beat frequencies. But it's certainly possible we don't have that problem. Let's do that experiment I wanted to do, and then, yeah, we could try just doing a bunch of filtering. I mean, I've already got this data going into an A to D converter. We could just, I mean, I think I need to do some boring programming before I can have that graph anything, but I could at least do a really basic low-pass filter and then print out the results to see if that looks better. Cable. for a little BNC breakout with alligator clips on it. Let's keep that on. Okay, we should have some power. I'm going to use the green channel as the sensor's power supply. Maybe I just don't even have my microcontroller in the circuit right now. So, pick a sensor. Use this sensor. Alright, so now we're triggering on a power supply on pulse. So we're just going to see what this looks like as we turn the power supply on and off. It looks like it only takes one of those measurement cycles to stabilize. Wait, why is that? What is that hitting? Is that like bouncing off my microphone up here? These have kind of a weird nonlinear distance response. But I think it's hitting something like my microphone up here. I want to make sure this can actually stabilize in the amount of time it has. I wonder if this sensor is reflecting off the side of my LiDAR. I'm not expecting it to give me such a large value when it's not actually hitting anything. How is this sensor? Let's try that one. Well, maybe for the one that's furthest from all the LiDARs, just to see if that was an issue. Let's try this sensor. do need a little breadboard. Does seem like if I have to sample these sequentially, it wouldn't be that bad. Oh, maybe this function generator just can't power this thing very well. That is supposed to be the power for the sensor. Guess I could try putting a transistor on this experiment. At least a capacitor. Try like a 1 microfarad capacitor. Just getting these super thin wires into the breadboard is annoying. If I were planning on doing more of this, I would probably solder these to headers. And then a little 1 microfarad electrolytic cap across the power. And let's monitor the power. Never enough grounds. Thanks, video card. Okay, it just needs power from the signal generator. Oh, I just have like no useful ground right now. Oh, that is still noisy. Better. At least now I have this on a breadboard so I can add more capacitors. Oh man, it would be so fun to do a laser harp with this. I mean, these LiDAR sensors they would be amazing for a laser harp. It would just be really expensive to do a laser harp with them. Okay, more capacitor. Try 10 times that. That's better. Yeah, I think it's not acting like it's supposed to because of all that power supply noise. But I think if I ignore that, I think what I came here to look for was how quickly this thing actually starts up after the power supply is applied. And I think the answer to that is roughly 50 milliseconds. So it looks like I'd probably have to power it on and probably throw away about 2 sampling cycles and then take one of those. And that just doesn't seem super viable. I think I'd be better off trying to filter out the noise. So maybe let's see how that is. Ash is asking, I would guess the spikes are mainly from the sensors as the modulation's being gated. Yeah, I think so too. Unless it's also that the MCU does some high Z stuff after each ADC sample. You mean the MCU in the sensor? I don't even know if these sensors have an MCU. I'd be, like, these are old enough, I would expect them to be an ASIC, but who knows? So the microcontroller board, so I guess the earlier question that I was missing is if those spikes are coming from the microcontroller board, but yeah, it's not even connected right now. Those are definitely coming from the sensor itself. Okay. I guess at this point I'm just asking myself if I want to commit to the trouble of wiring up all these sensors in such a way that, like, I'd probably have to undo if I replaced this saucer at this point. It's probably worth it. I can't really think of a way to fix this effectively just by changing the design of this saucer piece. And it seems like the angle is fine. Alright, well, I think I'm at another crossroads. Like, we could just barrel ahead and try to wire this thing up and see if we can filter it at all. I'm liking the idea of having a bit of infrastructure for graphing the results we're getting out of this thing before we do too much more, though. So this might be a good time to wrap up the stream soon and come back once I have some kind of graphing stuff working. Let's see how that other piece is doing on the printer. There's some stringiness on that side. Let's maybe take a closer look at that. It's probably fine, but oh, maybe it's warping. It looks like it's warping. I might have to reprint this with Raft. Yeah, warping. I'm gonna need to reprint this with a raft probably to keep it down. But let's look at what we've got so far. Oh man, that was a great cat. Look at that. Oh, what a good cat. Yeah, we're talking about you, little fuzzin'. Yeah, build plate adhesion issues are pretty common around here on my non-heated bed printer. That's fine, it comes with the territory. So, this is what I had. So this would go... So it goes kind of like that. So this would continue printing, and then there'd be an interface on that side. And then the actual nylon cords come out of these little arms. And this clamps onto the carbon fiber rods. So that was looking all right so far. Also, I was printing this using somewhat higher infill, and it seems all right. It's a little heavy, but I think it'll be pretty good. Can we do some destructive testing? So it does crack. Good layer adhesion though. It just cracked all the way through. It didn't split into different layers. Yeah, I think those print settings are fine. I just need to probably do this with a raft. Oh, let's, I've got to reslice this, don't I? Oh, I totally just made my hand start bleeding. Nah. Blood. that 3D printed piece put up a fight. Let's switch to this one. Curalicious. So this piece is going to be a little bit tall. I'm wondering if maybe I was using too much infill. I don't know. Let's try... So James was suggesting to wire the power together and ground together, and then hook all the other data lines up to headers. That's probably my next step. The reason I was not super excited about jumping to that before I was super confident in my 3D printed piece here is that if that doesn't work, I'll have to cut all that up to redo it with the new 3D printed piece. And that's fine. I think I'm to the point where that's the next step. I just wanted to be sure before I commit myself to it. Ow. That does actually kind of hurt. And okay, there's our brim. Oh, come back here, window. Oh. This is just not computing euphoria. It's like I have no mouse pad and half the windows I want to interact with are off the edge of my screen. James asks, or James Mastros asks, how warm is my shop? NorCal or SoCal? It's Northern California. The temperature varies a lot because the actual location here is pretty drafty. So it really depends on what the weather's like outside, and the weather outside changes over the course of the day. Okay, so that's uploaded. I'm going to wash off my wound and then reload the printer. Yeah, I guess it's probably time to just make a little wiring harness. Commit ourselves at least somewhat to this particular plastic piece. Wire and some pin things. So Roy says, what IR sensor is it? The sharp ones require capacitors to settle down the voltage noise. Yeah, this is one of the sharp IR sensors. I mean, I could put some capacitive filtering on the output. That might help. I also have just, like, the A to D on there is just so fast that I can do enough filtering in software that maybe I don't even need the capacitors. All right, let's just start wiring power and ground together. I don't want to switch off the 3D printer camera though. So we can at least watch it get started. Like it's got a tiny booger over at the end, but I guess it's stuck to the build plate. It's really amazing how easy 3D printing is to get started with now. I mean, it's still one of those kind of fiddly hobbies that requires some attention, but definitely doesn't demand nearly as much patience as it used to. Okay, so there's all the black wires. It's kind of a weird coincidence. I just met up with a friend recently who I haven't seen in a while. And they're doing another variant of this project that it's kind of an old art project that they're doing a new version of. It's kind of a thing that you stand in the middle of, and you can play with this ring of distance sensors, very much like this, that are attached to little like flame effects. So basically, like propane cylinders with valves and pilot lights. So when you trigger these sensors, it makes fire happen. And so the other device, it reminds me a little bit of this. It's just like much bigger. It's a big ring with these sensors all around it. All right, let's get some materials for this. It is tempting to put little numbers on all the wires for the sensors. I don't even know if I have label tape that small, though. As for the data wires, I might just splice on some of these. I could just take 4 of these and cut them in half. That should be plenty long enough, I hope. Yeah, we can just pretty straightforwardly splice this onto some jumpers now, and if we need a little breakout board with capacitors, I can add that later. Nice. The wire in these jumper leads that you usually get for breadboarding is just super thin and nasty. Like, it's mostly rubber or whatever the insulation is made of, like recycled trash bags. I mean, it's probably alright plastic, but there's just mostly plastic and then a couple of tiny strands of wire. So, a little dubious using these for power wiring. Even just for a handful of sensors, because each one of these does take like 20 milliamps. Okay, these are already stripped enough. That'll be fine. This is just going to be one big annoying solder bundle. using a couple of separate DC to DC converters for this. At the very least, I want one for the control electronics and one for the lighting. But I could also throw the sensors on a separate one because they are actually kind of power hungry. I think I do actually need to strip more of this. Just twisting together little bundles of 4, and then twisting bundles of 4 together. Now it actually wants kind of a big piece of heat shrink tubing. Don't have any good colors for ground, but I do have yellow. I think yellow might have to do. And another little bit of heat shrink on this side as a strain relief. Beep. Something like that. And then you can use many sources of heat for this, but my old favorite is the surface mount rework air gun. All right. And same thing with the reds. Oh, I just noticed Corey's message in the YouTube chat, which I think was about the message on my camera where it stops after 30 minutes. And they're suggesting you should try and modify the firmware to stop that happening. It's the 30-minute tax evasion thing for photo cameras. Yeah, exactly. Because it's technically not a video camera, it's a DSLR, so it has to stop recording video after 30 minutes. Yeah, and actually, I was going to just get around that by using Magic Lantern or whatever, or CHDK or whatever. I guess Magic Lantern. Always get the different firmwares mixed up, but whichever one is actually compatible with my camera. I think it's Magic Lantern. I tried that one and I was using it for a while. It had some good features, but I had problems with it corrupting my SD card, so then I went back to the official firmware. Just one of those things where, like, if it pretty much ever just deletes all my files, then it's kind of hard for the beneficial features to live up to that possibility, or to counter that possibility. Ash says heat shrink is great. I never used to use it years ago, like IPA, but I don't know how I did without it. I use the hot air station for heat shrink too. Yeah. And also, speaking of IPA, maybe it's beer o'clock. And then Chris, I think, was asking if this is the wiring for the distance sensors. Yep, these are the analog sharp distance sensors, the ones that take 5 volts in and give you kind of a sorted distance-related analog value out. They're mostly being used to see if something is about to hit the gimbal, so that we can avoid that. And then the 3 sensors are LiDARs, which will be partially useful for collision avoidance, but mostly are there for determining how far away the floor is for setting the height. And there are 3 of them, mostly so that there can be some redundancy, because the floor is going to be full of weirdly shaped objects, and so you can assume that whichever one is furthest away is probably a good approximation of the floor. While also correcting for the tilt of the entire robot. A little more heat shrink. About to try to cut heat shrink with pliers. That would go well. The A to D converter in here is just really, really overkill, so I can probably add some software filtering in my interrupt handler and filter it before I have to send the data over the network, and that might be really nice. Maybe that's what we'll do, because that seems like a pretty flexible solution. I can just add some software filtering, and it could even have coefficients that we can tune at runtime if we need to, either over the network or by setting things in the EEPROM. Oh, nice. Apparently, seeing the parts for this project helped convince Charles to get a 3D printer. That's pretty cool. And then a beer recommendation from Whisperfist. Cooper's Sparkling Ale from Australia. That sounds good. I haven't tried very many Australian beers. I'm kind of a sucker for IPAs. Like, I like my beers hoppy, but I also like to try new things. Oh, sorry about the hair cam. Jeez. I hate when I do that. I need like a heads-up display so I can see the DSLR viewfinder out of the corner of my eye. Actually, for various stupid reasons, I have a Google Glass that I am not really sure what to do with, which has been the case for a long time. And there's so many things about it that are bad, but maybe if I could just use the screen as a DSLR viewfinder, that might actually be useful. This was like one of the side effects of having a friend who worked at Google who was maybe a little too capable of talking me into things. Sweet. Oh, James Mastros says, thanks for correcting the color. Your hair is now the same color on the different cams, at least. I don't think I did that. I think that might have been a side effect of the lighting changing today. Because that is going to be very different depending on, I think, if we're in sunlight or not. I don't know, my hair is also, like, it can be different colors. Sometimes it's brown, sometimes it's kind of blondish, sometimes it's purple. I mean, some of those are natural, but... I mean, usually it tends to be kind of light brown. I haven't dyed it in a little while, although for a while I had a pretty common habit of doing purple. Alright, so we got red and black, and then we've got a bunch of these individual sensor wires, which looks super annoying. So let's just splice all of these to one of our yellow wires with some basic heat shrink. I think this heat shrink is what we'll use. Make a little bouquet. Gotta decorate all the wires with their little collars. There's something I find really satisfying about wires kind of threading through parts like this. Like little artificial forest that you're planting. But it only grows with your explicit effort, which is a little bit different than a regular forest, I guess. really did strip these to be super short. Just gonna twist these together and then hit them with the soldering iron, and they'll be good. Don't need to worry about any really fancy joints. I'd been doing electronics for so many years before anyone had ever told me about, like, what is the lineman splice, the really nice one that everyone tells you to use for wires that are under tension, or any of the array of splices you can find in NASA manuals. That's just, there's so much there to go into. I'm still a little shy about using crimps because I've had so many bad crimping experiences. I mean, I've got a couple of combinations of things where, like, okay, I know I have the right crimps and the right tools and I can make these work, but it's just so easy to make a bad crimp if you don't have the right stuff or you don't use it correctly. I remember this job I used to work at, we had this really nice crimping tool, but I don't think we had the right dies for it, so people were always making these terrible crimps because it was this nice tool that didn't have the right settings. Oh, this one came loose and now I'm having to redo it. Let's solder a few of these. I know this isn't all of them, but... One, two, three, four. 5, here's another one. Oh, I'm doing a lousy job at the photography today, sorry. Oh. Just catching up in the chat. It looks like there's a discussion about the demo scene. I've never been to a demo party. I think it would be really awesome to go. I'd also like to actually just make a demo, which I've never really done. I've certainly been inspired by the demo scene, but haven't really made anything of my own that I'm proud of. Looks like 2 of these left. Yeah, Tuco does have a pretty great life. He still complains a lot, like everyone who has a good life. But, you know, it's what cats do. I think he just thinks about things really differently than I think a lot of people he's been around would. Like, you know, the things that are good for a cat, especially a cat like Tuco, are just so different from like what, like he likes, you know, tearing things up and chasing them, and you know, he likes running really fast. He likes, you know, being in high places. I think it's, I don't know, I like making him happy, but I also understand that maybe some things that like people think would make a cat happy actually doesn't, and that there's some trial and error to be expected. One of my neighbors was getting rid of this like plywood cat hangout that is just like a box with some holes in it. And Tuco and I saw it in the hallway, and he just started experimenting and climbing around on it, and so I had to take it inside, and I think he still likes it. I've caught him sleeping a couple of nights in there so far. He seems to have a pretty good variety of places to sleep these days. Like sometimes he sleeps in bed next to me. There's like a couch in the loft now. It was a recent donation from my friend who just moved away. And Tuco likes sleeping on there a lot. Sometimes he sleeps down here. Oh no, did I forget? Oh no, here it is. Whew. I thought I was missing a heat shrink on one of these. I'm just sliding all the heat shrink over the joints. The wire on the breadboard jumpers I used for the microcontroller end of this is just super thin, so I'm a little worried that that's going to be the weak link here. Some of these joints I managed to fold it over so that there's a bit of a strain relief, but some of them there's just no strain relief really, so this might be a weak point. It'll be nice having the LEDs attached so that I can just run some software and have some bling anytime I want it. It's always a nice feature. Oh, this heat shrink was not positioned really well. That's not great. Well, it's insulating it. Alright, well, that's not optimal, but it'll do for now. Might be time to actually make some connections. Retro machines are super fun. Okay, let's maybe hook up the analog signals. I need my cheat sheet. So, I'm going to try to do these in some kind of reasonable order. I actually have not numbered these sensors yet. Even in the CAD, they don't have numbers. I'm going to decide that this one is number 1 because it's next to one of the carbon fiber holes here. And yeah, sure. And then I'll go clockwise from there. Well, 0, not 1. 0 is where it starts. 0, B1.6. Oh, should these go through the hole? Let's save that part for later. So we're just temporarily plugging them into the micro. So, okay, PE3 on B1.6. There it is. PE3, PE2. I think these sensors will come in 2 banks of 4, the way I did the pinout. That was just where I had the convenient analog inputs. Yeah, down to PE0. We can also experiment with firmware filtering, maybe. Might be a good thing to do. PK0. And I think I even saw a nearby ground in +5. Yeah. Okay, ground +5, 8 analog inputs, accelerometer, and then a bunch of stuff that's still not connected. Mainly the LiDARs and the LEDs and the gimbal. Okay, 5-volt power then. This will be powering up all the IR sensors for the first time, I think. I need to increase the current limit on the supply a little bit. The limit set to 0.3 amps. Let's try a 1/2 amp. Okay, so now it's drawing 0.37 amps, which seems better. And do we have data? We have data. Clear. Oh, come on. Okay, there's all the IRs. They look a little noisy, but it's kind of hard to tell what's going on. Let's see if we can at least just get something from all the sensors. Looks like the case. So, it would definitely be nice to get more visualization from all this. Where is that lag coming from? Is that in the terminal emulator? Because my robot sure is not buffering that data. If there's lag, it's definitely on the receiving end. I think this is the Python program and or the terminal emulator lagging, so that's also something that I just need to rewrite that code in Rust and WebSockets and JavaScript probably. And then I'll, not that those languages are specifically better or anything, but right now the reason I'm not putting much effort into it is that it's written in a way that's very temporary. And once I'm starting to write this in a less temporary way overall, then I'll put more effort into it. Anyway, aside from all the major caveats of the software not really telling us, not really giving us much of a visualization, it seems to be all right. So maybe that's about where to wrap it up for now. Because I think the hardware here is doing all right. I just need more of a way to actually see what's going on. And I don't really want to write yet another piece of throwaway code for this because I think I'm actually going to want something that I can keep using for the real robot at this point. So at that point, so what that means is I think what I want is to have a little Rust process that's actually doing all the stuff that I want to do the robot. So all the stuff that needs to be done in process. So, you know, running control loops that try to keep the robot at a stable height and try to keep it from running into the walls, things like that. Taking commands, probably over WebSockets, from other applications running on the local machine and other machines on the network. Oh, Ash says I need to learn how to use WebSockets, etc. It would be so handy for many of my projects. I agree, they're super handy, and I would definitely suggest just trying it. Like, on the JavaScript end, at least I found it to be surprisingly simple. It's basically just you call one function to make an object, another function to send a message, then you have an event handler for receiving messages. There's a little bit of complication that comes into play if you want to deal with like binary versus text messages or like sending JSON, but if you just want to send text, it's really, really, really simple. You don't even have to really know anything about the protocol. You can just call a couple of JavaScript functions. And then depending on what language you're writing the server in, I found some pretty nice backends for that. For the thing that we were just experimenting with for like graphing the gimbal output and all that, that was a Python WebSocket server that was then talking to the gimbal over serial. And that used the Python 3 WebSockets library that you can find on PyPy. That was really nice. I haven't looked into what's available for Rust yet, but I'm sure there is something, and it's probably pretty good knowing the state of network stuff for Rust at least. All these spurious things we're getting down here, the ones that are all zeros, that's actually just noise coming in on the serial port that would normally plug into the gimbal. If there's just like a momentary pulse on that port, then the UART could see that as a start bit. And then if it sees that, and then all zeros, and then a 0 stop bit, then what do you know? It's a 0 byte. So that's why we get these packets full of zeros every so often. Oh yeah, and then the HTML parts of doing like a WebSockets UI, that stuff can be a little daunting just because there are so many different ways of doing web technology. I mean, if it's helpful, you're welcome to look at what I did with the script for Tuco Flyer, or for the gimbal rather, and copy the parts of it that make sense too. I was trying to find, oops, not getter. If you look at the FY gimbal repository, that has a little parameter UI that I wrote to just give me a bunch of graphs and sliders. And I don't know, if you feel like reading this, it's written in a very straightforward manner, but it doesn't have any separate documentation or anything, so you might find better resources. Oh, and these are the packets we're transmitting from the joystick. We're still doing that, but we don't really need to be. Yeah. Anyway, there's other stuff we could do. But I think this is probably a pretty good wrap-up point. I'm going to try to start some kind of control software for this in Rust. I just need to read some more Rust documentation so I can actually structure it a little bit better. And then on this side, I think this is looking all right. We just need more 3D printed parts. We need to actually graph this data to see if that looks good, but it's doing better, I think. How's our 3D print? Looks like we're printing the raft still. Getting all rafty. Is there a moment of Tuco? I still got all this tea. Happy Sunday, everyone, if it's Sunday when you're watching this. If it's a different day of the week when you're watching this, then I hope that's a good day too. If you're watching this and it is no day of the week, then I'm kind of curious what's going on, because that sounds pretty exciting. Maybe you found a way to get out of this monotonous universe where all the days end in Y, and there are only 7 of them. Well, happy hacking, everyone. Catch you on the next stream.